we can actually get our elevation surveys to an accuracy that previously was only ever gotten to with other technologies. So we're at sort of the 10 centimeters. So we can tell you if something is the road or the curb. Right, so it's quite accurate, but we do it all from satellite. So we tend to complement those sort of big, heavy civil industries like mining, major construction projects. We have been using the convolutional neural network side of deep learning for, I think, about 11, maybe 12 years. So we're very heavily integrated into that side of the AI space.
Hello and welcome to Horizons, the World Geospatial Industry podcast. Guest today is Andrea Krupa, President and CEO of PhotoSat. Andrea, welcome to WGIC.
Thank you very much for having me.
Great to have this conversation. 30 plus years, 3,000 plus projects, and 75 countries with a crisp mission to provide better data for better decisions. That's a fantastic journey of PhotoSat. Can you help us give an overview of PhotoSat's journey?
Definitely. So PhotoSat was founded in 1993 by Jerry Mitchell, who's a geophysicist. So Jerry had come out of originally the mining exploration industry and then had moved into oil and gas. And so when he decided to start his own company, he made the decision that he really wanted to be a service provider that had boots on the ground experience. So he likes to call it mud on your boots. And so from there he started PhotoSat. At the time it was actually RGI. So we were known as RGI for the first 15 years of our existence. And we were really focused on the mining exploration industry. So we started in Vancouver. And so in Vancouver, Canada, there's a very large mining exploration, junior mining industry.
Yeah.
And started here supporting the mining exploration. And one of the things that he was doing was constantly testing and tinkering with new ways to do things, new ways to process data. It actually PhotoSat started in his basement in 93. And as the company slowly built, he always had a big R&D department. So PhotoSat always did all of our own software. Everything we have is proprietary, done in-house, built in-house. And as we started to get better and better on the technology side, we started to do things nobody had done before. So, for example, we do topographic elevation surveying, which I think we'll probably talk about later, but a very, very high accuracy from satellites. And so that got us into new markets. So we went from junior mining exploration to oil and gas exploration, helping doing surveying before seismic surveys. And we also then got into monitoring and surveying of operating mining facilities and heavy civil facilities. So we work with these companies all over the world, and one of our core values, and that comes from him being that geophysicist with the mud on your boots, is to always create value. And so that's really how our journey has evolved throughout. And then for me personally, I've been in the company for about 9 years and kind of came into the CEO role 3 years ago.
Fantastic. Great. So you briefly mentioned PhotoSat facilitating elevation surveying data for engineers, right? So can you tell us more about this capability and what sectors or industries are benefiting from this data and how?
Yes, for sure. So elevation topography is not new, right? It's not new in the market. Engineers have been using topographic surveys to create their plans for as long as they've been creating plans, really. So what we do, what our capability is that is different is we're using stereo satellite data. And so typically we think of that and we think of, more of the mapping space where you're getting topographic elevation data, which is maybe 1 meter, 50 centimeters vertical accuracy. With our proprietary technology. So we've been using convolutional neural network, deep learning, machine learning for about 11 years now. We can actually get our elevation surveys to an accuracy that previously was only ever gotten to with other technologies. So we're at sort of the 10 centimeters. So we can tell you if something is the road or the curb, right? So it's quite accurate, but we do it all from satellites. And so that's what makes us unique. So when you're thinking about the industries, take the operating mining industry, for example, these mining companies have mines all over the world. So in traditional surveying methods, they have to have people on site, have people there actually doing land surveying, flying drones, airborne LiDAR, whatever that might be. And we can actually do it all from space. So we tend to complement those sort of big, heavy civil industries like mining, major construction projects, wind farm development placement, mining development, not just mining operations, and as well as we've done some work in the major dam construction, like hydro dam construction.
All right, that's impressive. Okay. I also, when you also spoke about geological exploration, I want to understand how important is alteration mapping for the success of geological exploration, and how do PhotoSat's alteration mineral maps support geologists?
Yeah, so if you're thinking about exploration, mining exploration, typically the first step is to decide where you actually want to stake your claim, right? Where you want to be doing your core sampling or your drilling, sending people on the ground with handheld spectrometers, whatever that is. So the first big question is, where do I even want to send my people? And that's what alteration mineral mapping can help with. So different deposit types, epithermal deposits, whatever it might be, will have different minerals that come to the surface. So it's not the gold that's at the surface. Maybe it's buddingtonite or kaolinite or some other mineral that's at the surface. And with alteration mineral mapping, so that's using multispectral or hyperspectral, sometimes thermal data, we can actually we can use that to look at those outcrops and see what minerals are actually on the surface. So what happens very high level is every mineral has a spectral signature that comes off of it. And so when you're looking at it with a multispectral or hyperspectral camera, you can see the spectral signature. And then we can identify from that spectral signature what the actual mineral that's there is.
Yeah, yeah. Okay.
And so,
Great.
yeah, and so that just helps them pinpoint, okay, this is where we want to send our field staff, or this is where we want to do more development. So we do it on a large regional scale, and then also we have higher accuracy sensors that can do it on a smaller property scale. But it's really to help them be more efficient in their use of time.
Okay, all right. Andrea, you mentioned about PhotoSat supporting mining activities and not just operations, but also development. Can you help us, our viewers, understand more about these capabilities? And is PhotoSat able to support your clients with application development as well?
In terms of application development, so when you're developing a mine, so now you've done step one, you know where you want to have your mine, you've done all your core samples, you've decided it's feasible. And then step two is now you start to actually plan what the mine's going to look like. And so a lot of the times mines are in these very remote areas of the world. So you have to look into, are we going to have to do roads? How are we going to actually transport the material out? Is there a rail line nearby? And so we work with engineers to figure out where they're actually going to put and build all of those things. So that goes into then their pre-feasibility study or their feasibility study. And they need to submit all of those things to actually get their permits for the mines. So we're not necessarily submitting the applications on their behalf, but they're using our data to design where things are going to be and how they're going to look and do that in the most effective way possible. So if you have to do a road that's 300 square kilometers versus a road that's 500 square kilometers, that's a big difference in terms of how you're actually designing your site. And then from there, once the site's actually being constructed, typically what's happening is the sites are being constructed by your, or designed by your engineer sitting in their office in um, Phoenix, Arizona, or here in Vancouver, and they're being constructed in Chile or Argentina or somewhere else. So oftentimes what happens is the site gets designed, the designs go down, and then they have to get confirmation that it's actually being constructed to plan, because that's really big for development permits as well as compliance, regulatory compliance. So we're helping them do all their as-built drawings so they can see how the site is developing and being constructed over time to make sure that they're safe and in compliance as well through operations.
Right. Okay. So, in providing this data, is PhotoSat also integrating deep learning technology? In fact, you briefly mentioned at the beginning of this conversation, right? So can you help us understand how PhotoSat is integrating deep learning technologies and the latest into the data products?
So yeah, so PhotoSat, I often joke that if we had known that deep learning and AI was going to be so big, we should have called ourselves PhotoSat.ai. But we have been using the convolutional neural network side of deep learning for, I think, about 11, maybe 12 years.
Okay.
So we're very heavily integrated into that side of the AI space. And
Mhm.
so we use it in a bunch of different ways. I think one of the things that we do that's slightly different is most people who are doing, say, elevation or elevation product, for example, are using something called photogrammetry, right? Photogrammetry is pretty common in the industry. We don't use photogrammetry. We haven't used photogrammetry since 2014. We use a completely different process that we actually originally developed from seismic surveying data cubes, or that how you would process a seismic surveying data cube, because Jerry was a seismic surveyor at a point in his career. And then we started to augment what we were doing there with deep learning, with convolutional neural networks. And because we have so many projects and so many clients, and we've been around for so long, we've actually developed our own massive training data set that we've used and that we do continue to use. And we get a lot of feedback back from clients. So we get verification that what we're producing in our training data set is correct. And so that's how we integrate it into all of our different products, actually. It's part of our core algorithms and our processing.
Okay. Would you want to cite any recent implementation or a case study and how you're supporting your clients with the deep learning technologies?
So, I mean, I think for us, it's every single project we do uses deep learning.
I see.
Yeah,
Yeah.
so it's every single project. We'll be presenting a paper coming up here, I think next month at a mining conference with tech, and all the work we've done for them uses deep learning. There was another paper that Winsome Resources, we were looking at lithium, who are looking at lithium exploration, and we were looking at, okay, can we train models to help finding lithium-bearing pegmatites? That's also all using convolutional neural networks, our training data sets, and using that deep learning to help us identify those pixels and the spectra and the pixels that we're looking for.
All right, great.
Yeah.
I've noticed, Andrea, that PhotoSat is in partnership with several geospatial companies, and some of them are WGIC members too.
Mhm.
How is PhotoSat leveraging the strengths of its partners in delivering data and solutions to the customers?
Yeah, I mean, I think PhotoSat does everything through partnerships, mostly through the satellite companies. So we don't own our own satellites. We're purchasing data, tasking data for our customers. And that in itself is just it's part of our business model. I think we've been
Yeah.
partners with Maxar, who before was DG, and there was GOI, and there was all the different ones since the mid 90s. And so one of the nice things about all the different partnerships we have is it allows us to test different concepts. We do a lot of R&D, and so we can say, okay, we have a customer that has this problem. what partner do we have that has this industry expertise? Or what partner do we have that has this sensor that we think that we might need for this? And then we can kind of bring that into our in-house innovation lab that we have.
Mhm.
And also we can use partners as well, and the relationship we have with partners to access industries that we might not be in, right? As I mentioned, one of PhotoSat's core values is to always create value. So part of doing that for us is having a really deep understanding of who our customers are. I mean, we have a lot of geomatics engineers on staff who have been surveyors in the past, and we have geophysicists who've worked in mining exploration and geologists who've worked in mining exploration. So if we're in an industry or if we get a request from an industry that we don't understand, we will pull to our partners for that sort of deeper subject matter expertise that we may not have. We believe that's how we create value as a company.
That's cool. So, Andrea, PhotoSat has been a very valued member of WGIC. I just want to understand, in fact, curious to know what encouraged PhotoSat to join WGIC.
Yeah, so there was really two pieces to that. One is um, your executive director, Aaron Addison, is a very convincing human being who I've known in the industry for a number of years. And he actually really helped me to see the value in it. We weren't a member, and we had through a lot of conversations. It was about, you know, really understanding what the industry is doing and not living in a silo, right? We're
Yeah.
very embedded in our mining industry. We're very embedded in the satellite side of the industry. But there's a lot of really interesting things that other people are doing. And understanding what those are and how we might be able to collaborate as a community. I think for me is really intriguing, and I think where I see the value in that now. And once again, and Aaron is a very convincing human being, and so really getting having those conversations and seeing where he'd say, "Hey, did you know that these guys are doing this, and this company is doing this, and this research is happening here," and then starting to get really curious and intrigued by it.
Fantastic. I'm sure
Yeah.
you're finding more value since you joined the
Yes,
organization.
definitely.
Great. Andrea, just want to understand your perspective about the industry trends and the role of WGIC. We are noticing the practice itself, the geospatial practice itself is witnessing a rapid change, and the systems becoming more dynamic, complex, and also interconnected. How do you see and what do you envisage for an industry body like WGIC moving forward in making a meaningful impact in the industry?
Yeah, I mean, I think there's things that WGIC is already doing. There was the paper, the AI paper, and the conference that was just had down in Denver, which I attended and I thought was really fantastic, right? I attend a lot of conferences, but one of the things that I thought GIC was doing really well and seems to continue to do really well is pulling in outside expertise
Yeah,
that
absolutely.
beyond just what's in geospatial. I think as an industry, the geospatial industry lives in a bit of a silo.
Mm.
Um, and somewhat we like it like that. And you can see that because we use acronyms nobody understands. And we say things that you need, either a PhD or 10 years of industry experience even though it's
Really
actually
good.
pretty basic. Uh, some of us are doing rocket science, but not all of us.
Yeah.
So we sort of seem to do this on purpose, and I think the WGIC is doing a really good job, and hopefully continues to do a really good job with making the industry attainable for other people, because it also will help us as an industry understand what the use cases are. I think
Mm.
one of the things that the industry tends to do is we have this if we build it, they will come mentality where, oh,
Mhm.
well, we're just going to build the coolest thing, and obviously someone's going to need it. Whereas I think where the industry is going and has been trying to go to for a while is, oh, there's this problem, and maybe we can build a solution for it. And I think WGIC, with bringing in outside influences, outside perspectives, and keeping those dialogues, is going to help us bridge that gap that we've created for ourselves.
Fantastic. That's something together we would certainly achieve. Thank you so much for your insights and this conversation, Andrea.
Thank you. Thank you very much. I really appreciate the time that you've given me.